Hey everybody, it's May 2nd, 2022. It's one of our last lectures for the computer science class, Introduction to C++ Programming. There's no one here today, so it's a little awkward, but I'm still going to cover the material. We're not learning anything new, but we're going to take a project from start to finish and work on something like that. What I have here is a link to Professor Redden, your CSCI 2 teacher for this next fall. He's got a secret code book up called Substitution Ciphers. And so we're going to look at the rotation cipher and see if we can code it up. So a rotation cipher let's take a look at this chapter 1 on it. And there's some history to it. It goes back to Caesar. Caesar did a rotation 3 cipher. Rotation cipher is taking a code, a message, and encrypting it. So rotation, and the way it's done by rotation cipher is rotating around the letters of the alphabet. So if I go back to his home page, let's click back, where you can see it. This little code wheel right here, we can actually see it lining up. Let me open up the chapter 1 in another tab, but we'll come in here and zoom in on this disk. So he's currently got it set up where it's rotated 13 characters. But the way it's designed is we can do A, B, C, D, E, F, G. This will be our start. And our finish is we rotate, like if we go 3 letters, I'm going to do 1, 2, 3, and I can do A here. So I'll do a few letters. So let's see if I can make a quick sentence real quick. And I like let's see. All, I got A-L-L. I didn't want to do the whole alphabet. I like all. Let's just do that. So if I want to encrypt it, what I'm going to do is I'm going to go and look for the letter that matches it. So I is going to rotate to F. And everywhere I have an I becomes an F. The L rotates to an I. K goes to H. And E goes to B. A, if I wrap this back around, this is Z, Y, X. A goes to X. So it wraps around when you get to the end of the alphabet. And so this would be my code or message. This would be my secret code. And when I go backwards, I have to reverse the direction. So you need to know how many of the letters are shifted, because if I shifted 4 letters, it changes everything up. He's got a picture of the code book right here. It's linked 3 letters. He's got it going the other way. But his has got the same combinations that mine got. A and X, B and Y, C and Z. So apparently the rotation goes the other direction. So what I have here is going the other direction. This is like a rotation 23. What's on the screen is rotation 3. The plain text matches up with 4 letters later. So A goes to D. So he's got this plain text here. This is a phrase associated with Caesar. I came, I saw, I conquered. We have a website called Rot13. It's a, well, not we. There's a website. But you can do any rotation cipher and explore how this works. So I came, I saw, I conquered. Gets us this code down here for Rot13, but for Rot3, rotation 3 or 3 character rotations, we have this. So I'll write this over here. Rot3. I came, I saw, I conquered. Goes to LFDPH. BD, another L. Then B, DZ, L, FRQTXHUHG. Now, if it's got the spacing like this, we can see the letters. Like we know when we write in the English letters, the only letters that come up solo are I or A. So if I were trying to decrypt this without knowing where to start, I would start going with, is this an I or A? And I would try some different letters and see what I could come up with. So if I wanted to decrypt it, let's just copy this and put this at the top. Under another rotation 3 cipher, it gets worse. So rotation 3 isn't the one that works. When we go, instead of going forward 3, we got to go backwards 3. Backwards 3 would be like going 26, 25, 24. The next stop is 23. So if I check rotation 23, notice it decrypts it. So rotation 23 off of this one will be back to the original. So whichever one you're doing, if we go forward, well, we'll look at that more in a little bit. I wanted to see if we could code this up. Let's make this a class. So let's go into our program. And I already called it Rotation Cipher. I made a module here. And what do we need to include? We need, let's get rid of that caps lock. We want to include the IO stream. We're going to do, well, since we're going to be putting in a string, we'll do include string. Maybe we'll include C time in case we want to do something random later. That's probably pretty good for now, using namespace std. And let's set up a int main void. Oops. Got to return a 0. So let's just see if we can do something without making it a class yet. Let's just let's make the string. Let's put in, this was the Caesar's message. So we'll put it in. I came, I saw, I conquered. And I need an equal sign in there. So how can I rotate this? So what I'm aiming for, if I do rotation 3 for the Caesar message, should be L FTPH L VDZ L FRQTXHUHG. So it sounds like I need to go through it a character at a time. So I think we're going to need to do a for loop. And we'll do I less than Caesar message dot size. And we'll do I plus plus. And I don't know what's going to happen yet, so let's just take a look at some of the values here. Let's do, let me make an alphabet letter, string alphabet. And we'll call this lower. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. Oh, I did some stuff out of order. Q, R, S, T, U, V, W, X, Y, Z. I really do know my ABCs. It's not that all that clear. Now, if we do the rotation 3, how should this look under rotation 3? Well, I'm going to take this and dump this in the online one and see what we can come up with. I'll put this back to rotation 3. And I'm going to get this. So I'm going to copy this and put this in that code as a comment, just so I can take a look at it. Under a rotation 3 cipher, this is, so it starts at D. In fact, maybe if I do this right, now they're lined up. Look at that. I got it lined up. I like that. Okay. So I can't just say I want to turn A into D. I mean, like I could. I could say if alphabet lower bracket I, like character equals A, then alphabet lower I equals, under transform is D. I could do that, but I don't want to do that. And remember, for the if, we need the comparison operator. There we go. That should say if alphabet lower. Let's just do alphabet lower 0 for now. We know it's gonna work because that's the first character. But then just to test it, see out alphabet lower and no. So A should turn into D, and that's the only thing that's changing. So I should have the alphabet with D, B, C, D, E, F, G. And I do. D, B, C, D. That's just one character. To do this, I would have to do an if statement for every single letter. And oh my goodness, that would be tedious. 26 letters, that's just lowercase. If I wanted to do capital letters, I'd have to do another 26 if statements for that. That, while it works, that's not what I want to do. So I'm going to comment that out. Something that we can do is we can use the Ascii table. So let's go over, I've got the Ascii table already loaded on one of these pages here. And we've got the characters is what we're looking for, and the decimal equivalent or integer equivalent. So my lowercase letters start at 97 right here, and they end at 122. And my uppercase letters they start at 65 and they end at 90. So let's see if we can do something with that. So I'll put this up here, and I'm going to change this to say alphabet lower. We're just going to work on the alphabet lower one right now. So what I could do is, well, I could make a character, say like char temp. And in my loop, I could just say temp equals the alphabet letter, bracket I. And let's see if that works. See out temp and L. I just want to make sure everything's working as I want it to. I should get one letter in each row, so it should take up the page. And does. I got A through Z that way. That's good. So maybe let's turn it into an integer. So it's turning into one of these numbers. Maybe we'll call a new one an int value. So we're going to say value equals. We're going to take the integer or the temp and turn it into an integer. So let me see if I can expand this to have this say what the ASCII code is for it. So temp equals, it's going to show the character letter, we'll say equals, and it'll show the integer value for it. So yeah, it's working, 97 to 122. Okay. So if I want, A has to turn into D, right? Which means D on the ASCII table is D. 64. Nope, 100, sorry. Decimal version 100. So 3 higher than 97. Which makes sense. We're rotating at 3. So maybe that's all we got to do is we're just going to say, maybe we'll just say value plus equals 3. So this will add 3 to the value. And so this is like, maybe I should put this after this. So I'll put this down here. And now maybe we'll say see out like yeah, we'll do it all in the same thing. Let's put some tabs in here. Which means I gotta put this above it. Value. Well, this should be value minus 3 because I'm gonna rotate. I added 3 to it, so then this will just be value. Okay, so let's see what happens here. All right, so this is match up with what we know. Let's come look at the Ascii table real quick. So 97 becomes 100. That should turn into a D. That's correct. Under the ROT3, we know that I becomes L. Let's make sure that works on our stuff. I was 105. It becomes 108. 108 is indeed L. I came. C is 99. Becomes 102. 102 works. So it looks like it's working. So maybe we could just turn these back into a chart. So I'll add that here. These slash T equals, put a space, and now I'll put that new value back as a chart. I'm just trying to see what it looks like. Does it turn my letters the way I want it to? Whoop. So A turns to D, U turns to X, W turns to Z, X turns to parentheses. We have a problem. I need 120 to go back up to 97. So one way we can address this is I could just say, one option is to say if value is greater than 122, then I could do value value equals value minus 26. That would reset me back to the start of the alphabet, right? Does that work? Look at that. That works. So X goes to A and Z goes to C. So that would loop me around. That's not a bad solution. So I could apply this down here. Let's put this in my thing right here. And we won't do alphabet lower, we'll do Caesar message. Maybe I'll make a new string so we can start adding stuff to a new string. So string encrypted message. And we'll just start it off as blank. And now when we get around to here, what we'll do is I don't want to do the C out every time. What I want to do is I want to take that letter and add it to the string. So let's go encrypted message. Well, it's going to equal what we had in the encrypted message before. Plus char value. That's what we were doing above, char value. This is called concatenation, where we add letters onto the end of something. Let's see how this works. Let's see if this works. So I will, afterwards, I will see out Caesar message. And then right underneath it, we will see out the encrypted message. This should do the Caesar cipher, right? So we should be able to get what we got over here, the LFDPH, LBDZ, L. What happens when we do it? I'm going to comment out this stuff real quick. We saw what that does. So let's run it again. I'm getting close. I see the L, the FDPH, the L, the BDZ. I'm seeing the letters I'm looking for, but I'm getting extra letters, extra characters. What it's doing is it's doing the ASCII keys, right? It's rotating the space up 3 characters. Let's take a look at that. So here's space. If I add 3 characters to it, 35, I'd be at the hashtag. Right? And that's what I'm getting over here. I'm getting the hashtag. So I don't know that that isn't going to work. We're going to have to come up with something else. So let me turn that back off. And we will turn this back on and play with the alphabet more. So value equals value minus 26 is enough. And is there anything greater than 122 that it might come back and bite me? I don't know. Let's go take a look at the... That's right underneath something I'm looking at. What is underneath there? Stop doing that. So I got some characters I may or may not need. We're going to have to figure out something else to do here. So what else could we do? Well, we still want it to compensate for this 26, right? But only when it gets past the 122. So something else we could try is what if I did this? What if I took this and I subtracted 26 from it? Would that work? No, it's still just gonna get me down into weird number ranges. What if I subtract 97 from this? Then I get the range 0 to 25. So what if I subtracted 97 from that? I'd get 0 to 25. And then I could add my rotation value to it. That would push this up to 3 to 28. But I want 26 to be 0, and I want 27 to be 1, and I want 28 to be 2. That way I get back down to 0 to 25 again. Because if I do, then I could just add 97 again. So what kind of operation does that? Well, I could take it and do modulus on it, right? So we've got our temp character. Well, we got value. Let's say value equals integer temp. Just thinking this out right now. Value is my int temp. And I subtract 97 from it. So let's say this was z. So I'm getting 122 minus 97 is 25. Then I add 3 to it. This is step 1. Step 2 is add 3 to it. So we had minus 97 plus 3. 25 plus 3 is 28. And if I do the modulus on it, let's see what happens. What kind of modulus do I need to do? I want this, the z, I want to end up with a 2. So it looks like I need to subtract 26. It looks like I could do modulus 26. So 28 modulus 26 will get me the 2. Because that's what we need. Z has got to go back to C. This isn't C though. C is, what was C? Let's take a look at what C was real quick. C was 99. So I did the modulus here. I did modulus 26. It looks like I need to add that 97 back in. If I add the 97 back in, I'm back up to 99. And if I do char of 99, I get C. My Z right here will turn to a C. Let's see if I can type that up. So we said value equals integer temp, and I can subtract 97 from it. And then what did I say next? I wanted to add my rotation value to it, which I did. Value plus equals 3 right there. I got that right there. So this will add the rotation value 3. And dropping the 97 takes the character or the integer range down to 0 to 25. And then if we do the modulus after we add the 3, value equals value modulus modulo 26. This will take the character, the integer range back down to 0 to 25. And now we got to add the 97 back. This takes it back up to character range. So at this point, maybe I'll say temp equals char value. And then I don't need this thing. I've dealt with it with the modulo. So I'm going to change out my CI a little bit. It won't be value minus 3. Maybe I won't do temp in the first place. I will do alphabet I. Equals, I can cast that as an integer real quick. And I got char value is just temp. So does that work? Let's just make sure this works before I go and apply it to the Caesar message. It did. Look, we got the A, the B, the C for X, Y, Z. And our letters are looking good. Nope. We're missing some of the alphabet. What happened to it? Oh. Let's get rid of that. I saw a D in the front. That was what was screwing up. There we go. A goes to D, B goes to E, X goes to A. Now we've got a rotation. So what I'm going to do is we will copy this down below. We'll put that in our bit right here. And I will comment out the alphabet code again. Now we hopefully get this L, because this hasn't done anything with, oh, what does this do for characters? Is this going to screw up my commas and stuff? Do we need to address that? Let's just see. Oh. Char value, let's see. It says alphabet lower. That's why I didn't change it. Caesar message. Try that again. I'm like, why is it giving me the alphabet again? What's going on here? Oh, crap. So we got some big characters in it. Looks like the space is turning to a W. So it looks like maybe we need to put a restriction in there. So I'm going to break this little value line up into 2 steps. Let's say value equals int temp. And then I'll do value equals value minus 97. Because that way, now I can do something in between it where I say, let's just do all that encryption only if value is greater than or equal to 97 and value is less than or equal to 122. And that, okay. Now I've done it where it only applies to my letters. Maybe I need to do this after the loop. Or not after the loop, but after the if. All of these should be indented a little bit. There they go. Now I can see the lines matching up. Okay. Which means this can come back. There we go. Now it looks better. Let's see if that works. Now we've only restricted it to lowercase letters. So my capital I's didn't change. So maybe we need to do the same thing with capital letters, right? So let's do this same loop, but for capital letters. How does this change for capital letters? Well, the capital letters go from, we wrote that down. I got this over here. The capital letters go from 65 to 90. So let's do that. 65 to 90. Which means when I was doing 97, that's what I subtracted. Here I'm doing 65. I need to do subtract 65 here. That'll drop it down to 0, and then it works just like we said. Now I should get it. This did the uppercase conversion sequence. And this does the lowercase conversion sequence. So that encrypts it. So maybe I can make this a function. In fact, let's make this a class. Class rot_n. And, well, let's do structure. Just for time's sakes right now. So that way, because everything's public with structure, and I gotta tell it private if I want otherwise. So we will have string, we'll make it a user message. Let's just go user m. And we could say coded message, but I don't think we need it. But let's make a method. So my method is going to be encrypt rot_n. Well, this is, yeah, we want to do rotation n, but we're just starting off with rotation 3. So encrypt rot_n should return a string, right? And it doesn't need to take anything in because user message is already part of it. So let's come down here, down below, and make this a function or a method. And this was what was my structure name? ROT-N. So what I'm going to do is I'm going to take this for loop and move it down in there and see what we got to edit. I don't need Caesar message anymore. I need user message. And I think I still need these in there, don't I? I don't know that I need encrypted message anymore. Let's start off with coded M is a blank. Let's move this down below where I need it. And temp equals, that's where it goes, user M. And what we're doing is we're not attaching it to encrypted value, we're attaching it to coded message. So coded equals coded M plus that. And that's what we return, is we return coded M. So I'll comment out the string or the alphabet and get rid of the alphabet code. We got our Caesar message. We want to do both of this, but we need to we made a structure called ROT-N. So let's make an object real quick. This is object-oriented programming. We're going to make an object. It's of type ROT-N. Let's call it my message equals that. Let's make a constructor. It looks like we need a constructor, right? ROT-N string arg user M. I'll do it before this thing. And I need to do the scope resolution operator. I need to scope it out. And we will say user M equals arg user M. So now I can come up here. I've got my constructor. Let's just use that. Run my message, and we will just send in the Caesar message. And now I can see out my message. And I need to say dot user message. And we will encrypt it. See out my message dot coded M. And that's a method that takes in no arguments. Why is it not working? Let's just give it a run, see what happens. Maybe it does work. It does not work. Item does not evaluate to a message. Oh, shit. That's not the name of it. It's encrypt rotten. That's what I'm doing wrong. There we go. It looks like I'm not even using coded M. Let me put coded M down here, down below. Does that do my encryption? Still a no. Oh, I need to put it before the... Shit, these should be before the for loop. All of that should be before the for loop. There we go. Because it loses its scope as soon as the for loop's done. Let's try that. Sweet. All right. So we need a decryption option. Let's see if we can fine tune this. Let's see if we can do some refactoring. So what I'm doing is I'm taking temp and I'm making an integer. So let's just see if I can do all that stuff before. Value equals value. We're going to do minus 65. Then plus 3. That takes care of this line and this line. And now I need to do a modulus of that, so I can put this in parentheses. If I do this in parentheses, I can say modulus 26. And that does that part. And now I just need to add 65 to it. I like doing the plus in front. Which means I could do something similar down below rather than the only difference here is instead of 65, I needed 97. Oh, wait. I put that in the wrong spot. 65 goes in front. There we go. But that's a 97 here. I gotta do that over here too. Move that on front. There we go. And then this is 97 here. Let's just make sure that all works still. I'm going to comment all those out. That's my attempt at refactoring. Let's see if that worked. So I just went through one at a time and changed what was happening on the right side to make that happen. Yeah, I'm still getting what I had. Okay, so that refactoring works. So all of this X stuff is extra gravy. All right, so if I want to, that's my encryption method. Maybe I need a decryption method, right? So maybe I will make a string here. My temp. In fact, I'll do it right down here. String my I don't like doing that. No, I'm not. I'm going to do it up here. I like having all of my variables declared at the top. And what I'm going to do right here is I'm going to say my temp equals the encrypted message. And maybe I'll make two of them. My temp 2. My temp D, which is for decrypted. So decrypting it, we showed we had to do the same thing, but it was add 23. The rotation number changed to 23. So let's come down here, and everywhere I had a 3, I want to make it a 23. I need this to take in a message. So this has got to take in a string argument. Or we could make the... No, let's just do a string argm for string message. Actually, I'll call it user. No, I want to call it argm. We already got user m up above. And here we're doing a decoded message, so maybe I'll call this decode. Now, rather than doing the 3, we wanted to do 23. So I did all that should be the same thing. With this rotation cipher, the way we set it up, it was 3 and 23. We saw that when we did this thing right here. We rotated it 3, and then we come up here, and if I want to get back to the original alphabet, I do a 23 rotation, and I'm back to the original. So that's what we're doing here. So maybe that works. Let's give it a try. It's telling me I don't have a rot end, decrypt rot end up above. But I do. I see it right there. So why is it not down below? Did I spell it differently? So that one's off. So this is my constructor. I'm gonna put this up above. We'll have the encryption and decryption one right after the other. Oh, I already did have it. Why is... I made 2. I copied too much earlier. That might have been why it was angry. So I'll get rid of some of this flavor text in the decryption one. The commenting. Because it's just going the other way. And let's do a C out of my temp. This should just do what I just did. Nope. We want to do cout my message, and we want to pass in my temp. So maybe we'll do cout of my temp and then cout of my message dot decrypt. There we go. That's what I did wrong. Okay. So here we encoded it. Here we're decrypting it. Look, I got the original back. Isn't that awesome? Here I did rotation 3, but what if I want to do rotation n? Let's add an integer. Let's call it our rotation. Let's call it our rot number. Wait, what did I just cut? I want to copy and paste it. I want to do one there where it takes in the rotation number as well. So let's do, we're going to make a constructor for that. Arg rot n. We'll come down here. I'll make that. And here we'll set rotation number equal to arg rot n. And maybe we'll make a default one of 13. If they don't code it in, let's put in 13. Oh, wait, it's not rot n, it's rot num. So how does that change our encryption? Well, the encryption one, we don't want to have it modulate or shift by 3 anymore. We wanted the 3 to shift by n. So switching to n. We'll switch 3 to n on both of these. And what do we have to do to get the other one? Because I don't want to just say, how do I figure out what value to use for the other one? So let's say that's x. We had 3 plus 23 equals 26. So now I have my rot number plus I don't know what equals 26. So I just do a little algebra, right? Question mark equals 26 minus my rot number. And that's not, it's not n, it's rot number. So if I want to do the decryption, I got to do 26 minus that. So everywhere I see a 23, I'm going to replace it with 26 minus rot number. And I know I can combine these, the 97 and the 26 and the 65 and the 26. I could combine them, but well, first off, I don't want to. This helps me see the relationship between the two. And then maybe I'll put that in parentheses even though I don't need to. That like helps make it stand out. Now, what I've done is this should still work, right? Which just means I need to change. If I want to do test my code the way I had it, I now have one with I can submit an integer. Let me submit 3. So I should be able to get the same code if I submit 3 as my rotation number. Look at that. Look at that. Isn't that sexy? That's sexy. Let's test it out on a different one. Let's see what you know what? Let's just have the alphabet. No, I want the spaces in there. Gamers rock, but programmers are just as important. Are more important. Without the programmers, the gamer wouldn't have anything to play. But are they? Like without the gamer, well, I guess without gamers, programmers still have work. They just wouldn't be games. So the programmers are more important because they do other things. So if I do, let's say we do a rot 9. So that's what I should get out as my temp message. So I'm going to take this and plug this into my code. I'm going to send this in right here. We'll make a new one. Rot and new message. And we're doing a 9. And I'm just going to change this all to say new message. We already tested Caesar's message. He's old news. So I'm going to put this over here, bring up the code again. PJB, NAB, AXLT, KDC. Ugh. All right, but it worked, right? It works. Let's see what we get if we do a rot 13. Let's test the constructor without a rotation number. So I tried it with the 9 here. Now I'm just going to try sending it in without the number. So if I do it without the number, it's going to use this constructor right here. And this constructor defaulted to a rotation number of 13. So I should get TNZ ref. I think ref is easy to remember. And girl spelled all funny at the end. So let's go see if we get that. TNZ with a ref and then girl. There we go. We got that. We got that. So notice I don't have any couts in my stuff right here. It just returns the message, and the cout is done in the main. So the reason why I say do it like that, and I've been trying to get you to do this the whole semester, and some of you just aren't paying attention. You're watching videos and reading how to do programming elsewhere, and you're not even reading the instructions very well on assignments sometimes. I try to be clear, but guess what? On a final, I'm going to be really clear. I need separation. Separation means putting implementation up here, prototypes down below. Okay? Oh, this is implementations. Put a couple of them down. There we go. So what we're going to do while we still got some time is let's split this up. Let's look at doing a header file and a source file. And now I don't like what I named my rot n right here. So maybe I'm going to call it rotate n. That way I can have different header file names than what I've got my current file called. Let's just make sure everything still works. Because right now my current source file is called rot n. And I don't want it to be called rot n. Well, I left it that way, but I want my header file and my class file to be named, or my header file and my resource file to be named after my structure. So I'm going to call this, we'll make a header file, and I'm going to call it rotate n. And I'm going to make a resource file and call it rotate n here. And it's a CPP file. So let's see what we got to do. In rotate n, what we do is we put our prototype for the structure over there. And we're going to put anything we need in here. It looks like we need to include the string library. I didn't include this in the other one, but why is it not? Oh, string is in namespace, isn't it? Okay. I didn't need C standard library. I'm going to leave it in there. All right, so here I've got my rotation header. My rotation file needs to include that. And it also needs to include my methods. So I will cut all these implementations and move them over there. And if I come over here and include rotate n, or rotate n.h, I think I've got my separate. There we go, right there. This is what we wanted. So now I've separated it into prototype file called the header file, along with any libraries and stuff needed, namespaces needed. Then we've got our resource file, rotate n cpp, and they're both called in the main here. So let me save all, and let me see if this still works. Still works. So check this out. I could pass these files to someone else. Just give those files to someone else, and they start with a nice, let me comment this out. They start off with a nice blank canvas. They want to use my code. So they're going to do their standard message stuff. They're going to include the IO stream. I'm going to pretend I am Professor Redden, and I want to use Professor Jones's rotation end scheme. So I'm going to include the IO stream. I am going to, I don't know what Mr. Jones has used, so I'm going to include string. But I can come look at it. He's given me the header file, and the header file tells me he's using string, but he's already included it, so maybe I don't need it. But he's told me what commands I need to use. He's told me the setup here. Arg user m makes it pretty clear that it's associated to user n, and the integer must go to the rotation number. And the names of the methods are straightforward: encryption and decryption. So let's say Mr. Redden gave that to me. He's given me the header file and the C++ file. And I don't want to read the C++ file. I just want to read the header file and see what I got. And I'm going to make my own stuff. So I would naturally, automatically, I do this every time. That's how I set my stuff up. And I do a return 0. And I go, okay, well, I want to use Mr. Redden's code, which is my code, but we're going to say it's his for now. So I'm going to include that rotation file. And I'm going to come over to his rotation file, and I'm just going to kind of grab this, paste this over here in a comment, so I can see what kind of stuff is being used. So he's got a rotation method. So I want to do up a secret code. I'm going to go string. I'm Mr. Jones, but I want to talk trash about Mr. Redden. So Hefe's message is Professor Jones is going to win the Teacher of the Year award in less time than it took Professor Redden. Okay, I go, now I want to make it a little challenging. Let's go with, I'm going to use a rotation 11. So I see the setup here is I need to do rotate n, and then give it a name of the object. Hefem. And I'm going to pass in Hefe message, and I want it to be 11. and then I want to encrypt it. So I'm going to do fam.encrypt. And that returns a string. So maybe I'll make a temporary string here. We'll say temp equals that. And I go cout temp. So I don't know what the code is. I'm just using the header file. It's telling me the setup. And I know what rotation number is, but I would probably give this a little bit of a comment. Maybe we should comment this a little bit. This encrypts a message, encrypts and decrypts a message using a rotation cipher with a rotation key number of n. Actually, rot num. So maybe we should have the decrypt message includes an integer as well. Let's just make sure that what I got works before I go crazy. Let's see if that prints out what I think it's going to do. So I'm going to come here and I'm going to copy this. And I'm going to put that in the this over here. And I did 11, so 15 should get me back. There we go. Look at that. So I like that, but I'm already seeing a flaw in this. Like if I was Professor Redden, like how do I know what decryption number to use? Maybe I don't want to pass it in like that. I just want to decrypt a message. Say I'm trying to decrypt a message and I just have the message. So I need to have it where the decryption number actually takes in an integer. So maybe let's enhance this. Let's do decrypt argm. We'll also do the int arg rot number here. And I'll come over here and I'll put that in my decrypt message. And it has access to everything in its class, so I'm just going to say rot number equals arg rot n. And now save that. I'm going to comment, let's see, let me make another new temp. Temp equals, nope, that's not what I want. I want the one from the encryption. So let's say Mr. Redden gives me this secret code. Yeah, there we go. Okay. So I don't know what's being encrypted. All I get is the code. I want to make sure I can do the code breaking. I have the code. I need to have string temp back. So temp equals that. I'm just going to decrypt it. So I'll make a my rot. Just making a generic one. I'll pass in temp. Actually, since I have to set up the class, I'll pass in the number I think it is. I guess I didn't need it in there. Oh, look at that. What do you know? Well, let's just say I did. And I can do temp equals myrot dot decryption temp comma 11. So I'm replacing the old temporary with the new temporary. So we'll do it before and after. And now I'm trying to decode it. I'm trying to figure out. And that one works. But if I didn't know it and I wanted to go through them all, a fun way to like figure. Wow, I was trying to type 4, and I had my keys on DIE. 4 int I equals 0. Nope, I equals 1. I less than or equal to 26. I plus plus. I don't know which code it is, but I'm going to figure out I'm trying to break Professor Redden's secret cipher. So I'm going to do this. I'm going to pass in I. Because let's say he's got a whole book. And if I can just decrypt one sentence where it makes sense, I could do this. So what I'm going to do is temp is this. I will see out decrypting with rot number equals I. Gives me /t. I'll do /n/t, so indent. Keep putting my fingers on the wrong keys. So I don't know what his code language is in, what his cipher's in, but I'm going to try to decrypt it with this, and I'm just going to pass in I and figure out which one it is. So which one generates a sentence that makes sense? I'm going through them. I'm going through them. Why is it not doing it? Oh. It's decrypting at every loop. Bad. There we go. No, that's what I wanted. Oh, no, no, no. Let's make a temp 2. It keeps changing the string. That's got to go back in. We're going to say temp 2 equals temp 1 rotated I. That way, because otherwise I'm keep replacing it with a new rotation, and I'm screwing everything up. Trying to break his code. And I found one. Rot number equals 11. I got a sentence here. I can crack all of Professor Red's codes because he used the same rotation number. This is actually how World War II was won. Something very similar to this. It was a different cipher. There's a movie about it, The Imitation Game. It is about this very idea, cracking secret codes with a computer. They didn't have computers sophisticated like this, but that's my example here of a modern day one. Now, there's a lot more you can do with codes. I encourage you to check out his book if you find this topic interesting. What you can Google is I typed in, like if I go to Google, John Redden, and it was secret codebook substitution ciphers. If I just do the first one, it just gives me all the places I could buy it. But if I do this one, the one that says Prof. Redden Medium shows up. And that's where you can find his book. And he goes into a lot of things. He's got how to crack the code, which we did. Pigpen cipher is neat. The Vigenere cipher is neat. And he's also talks about, let's see, does he do it in this one? Because I was telling you, like when we had the, bring the camera back up. We have that I goes to F. Well, any single letter I know has got to be an I or an A. So how do they address stuff like that? Well, they can do regrouping of letters. That's not in this chapter, so maybe it's in a later chapter. He talks about it right here. I guess O is a possible guess for a single letter, like if you think it might be a song. But other ways to do it is eliminating all the spaces in the message. That way people can't identify word length. Word length is pretty big. If I see 3 letters, I'm going to guess it's the word the or the word and. I'm going to try those first. I'll try but, B-U-T. I'll try A-R-E. And I will see if those get me anywhere if I was trying to decrypt it. So eliminating the spaces in the word, in the sentence, makes it so it's a lot harder to read. Another way of doing it is breaking it up into manageable sets, like trying to memorize this or give this as a string of letters. Like if you're telling someone over the phone the letters, that's confusing. But if you have it broken up into spaces, like every 5th letter has a space after it, then it's easier to say 5 letters in a row and then you stop, let it write it down. 5 more letters. So there's a lot of fun stuff going on here. I'll show you the Vigenere just so you can see how much fun it is. I actually wrote up a code on it myself already. But what it does is it takes in a keyword. So let's say like the keyword is bacon. Bacon is the B is the first letter, it's 2. A is the second letter, it's 1. So it will go through a rotation cipher, but every letter changes the amount that it's rotated by. They're not all rotated by the same amount. So like on bacon, B is 2, A is 1, C is 3. I want to say N is 14 and O is 15. So if I make that my keyword, then the decryption thing, what it does is it just keeps repeating that. Bacon, 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 bacon. So if I do I like all, the first phrase I had, I like all. It's going to do this one is rotated by 2 to go with the bacon or the B. For the B. This one is rotated by 1 to go with the A. This one is rotated by C or 3 to go with the C. Then we got K is rotated by 15 to go with the O. E is rotated by 14 to go with the N. And now we're back around to the first letter of the word bacon. A gets rotated by 2 for B. So we keep going through this pattern of following a rotation scheme based on a key word. I use bacon because I like bacon and it's short, but you could use like a really long, hard to spell word, you know? So it's harder to decipher. The longer this word is, the harder the decryption process is. So there's more you can do with decryption. Just a little quick recap of what we did today. We developed a rotation scheme so we can encrypt and decrypt messages. We figured out how to do it just by doing one letter at a time. Then we tried doing value minus 26, but that gave problems with spaces. So we introduced the just dropping it down using modulus 26. And then once we got the code all working, we separated it out into 3 files: a header file and an implementation or resource file. This is why I don't want couts in the program, in the implementations, unless it says something like print or display. Because when he's like, if Mr. Redden's looking at my stuff, he sees this, he's gonna assume it doesn't have a cout because he doesn't want it to he doesn't know what the cout message is. Oftentimes they don't get to see what's in behind the curtain, you know, so they just see what you plug in. What I get out is a string. I'm going to assume there's no couts. So if I want to cout the string, I got to do it on my own in my main, which is what I did here when I did the new one. So that's why we don't include couts unless it says print or display. That's why we do separation into prototypes and implementations. This is all designed for teamwork. All right, I'm going to call that a wrap. Peace. On Wednesday, we'll just do a quick review for the semester.